In this episode, we're going to make Linux network configuration feel less like a tangle of files and more like a set of roles that different components play. New learners often hear names like NetworkManager and Netplan and assume they are competing tools you randomly pick based on preference. In reality, they sit in different places in the configuration story, and the confusion usually comes from not knowing which layer is acting as the source of truth on a particular system. When your network settings change and then seem to revert, or when a file edit does not take effect, it is often because a higher-level manager is generating the effective configuration somewhere else. The goal is to understand the concepts of what each system is for, what it controls, and what it writes or influences, so you can reason about where a change actually lands. That kind of reasoning is exactly what Linux Plus questions are designed to test, because it shows you understand how the operating system is assembled. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A useful way to start is to separate three ideas that beginners tend to blend together: the desired configuration, the active configuration, and the persisted configuration. Desired configuration is what you want the network to be, like a static address, a particular gateway, or a specific DNS server. Active configuration is what the system is using right now, which might come from a static file, a network-based assignment, or a manager that applied settings dynamically. Persisted configuration is what will be used after a reboot or reconnect, and it is where the system stores the instructions that will recreate the network state later. Confusion happens when you change one of these, but expect a different one to change, such as editing a file that is not the real persisted source on that system. NetworkManager and Netplan are both related to persisted and desired configuration, but they do so in different ways depending on the distribution and the underlying backend. Once you hold these three ideas separately, the rest becomes much easier to understand. Network Manager is best understood as a network connection manager that focuses on making network connectivity convenient and resilient, especially in environments where networks change. It is common on desktop systems and many server systems as well, and it is designed to handle multiple interfaces, wireless networks, roaming between networks, and connection profiles. A profile is essentially a saved set of settings for a particular connection scenario, like a home network or an office network, and the manager can bring that profile up and down automatically. Network Manager is also often integrated with user interfaces and higher-level tooling, which makes it friendly for systems where a human interacts with network settings. The conceptual point is that Network Manager wants to be the orchestrator that applies the active configuration and remembers it in its own store of connection definitions. When you change settings through Network Manager, you are typically changing the manager's idea of the desired and persisted configuration, and it then applies those changes to the active system state. Netplan, on the other hand, is best understood as a configuration abstraction that is commonly seen on certain Linux distributions to define network configuration in a declarative way. Declarative means you describe what you want, and a backend system generates the specific low-level configuration needed to make it real. Netplan itself is not the network stack, and it is not necessarily the component that does the ongoing connection management. Instead, it provides a structured way to define interface settings, and then it relies on a renderer, which is the component that actually implements those settings. On systems that use Netplan, it often writes out or influences configuration for a backend, such as one that focuses on server-style networking or one that integrates with Network Manager. This is where beginners get confused because they hear Netplan and Network Manager as separate names, but on some systems Netplan may feed Network Manager rather than replace it. The key mental model is that Netplan describes, while a renderer applies, and the renderer choice determines where changes ultimately land. This leads directly to the phrase "what changes where," because every network configuration system has somewhere it stores the truth that it will reapply later. With Network Manager, the persisted truth is typically a set of connection profiles managed by the service, and those profiles can include addressing, routing behavior, and name resolution preferences. With Netplan, the persisted truth is a declarative configuration file that Netplan reads, and then NetPlan generates configuration for the selected backend. That means if you edit the NetPlan configuration, you are changing the intended state that will be generated on apply and on boot. If you instead change Network Manager profiles directly on a system where NetPlan is feeding Network Manager, you have to think carefully about which one will win during the next regeneration cycle. The reason exam questions care is that they often present a symptom like settings revert after reboot, which is usually a sign that you edited the wrong layer. The correct answer is often not a specific command, but the concept of identifying the controlling system and editing the right source of truth. Another important concept is the idea of ownership and authority in configuration, because Linux often has multiple tools capable of touching network-related files. Beginners sometimes assume that if they can edit a file, that file must be the authoritative configuration, but a manager can override it or ignore it. Authority means which component is considered responsible for a setting, and the responsible component is the one that will persist it and reapply it after changes in network state. Network Manager tends to own settings when it is enabled and managing an interface, because it controls the lifecycle of the connection. NetPlan tends to own settings when it is the intended declarative layer for the system, because it will generate backend configuration from its definitions. If you attempt to bypass the authority layer, you can end up with a configuration that works temporarily but is not stable. That instability is one of the clearest signals that you change the active configuration without correctly updating the persisted configuration. Your mental checklist should always include the question of who owns this interface on this system, because that question tells you where to make lasting changes. It is also helpful to understand that these systems are often chosen based on the target environment and philosophy of the distribution. Desktop environments benefit from a manager that handles wireless roaming, user interaction, and multiple dynamic networks, which aligns with Network Manager's strengths. Server environments often value predictable, declarative configuration that can be managed consistently, which aligns with NetPlan's style when it feeds a server-oriented backend. This does not mean servers cannot use Network Manager or desktops cannot use NetPlan, but it explains why you see certain defaults in the wild. For exam thinking, you do not need to memorize which distribution uses which by default as a factoid. You need to recognize that different systems may have different management layers. Questions are often framed to see if you can identify the management context from the clues, such as references to profile style management versus declarative configuration. When you train yourself to look for those clues, you stop being surprised by differences between machines. Another layer that often creates confusion is name resolution configuration, because people expect DNS settings to live in one place. In practice, the active resolver configuration can be influenced by the Network Manager, by the declarative layer, by network-provided settings, and by resolver services that manage the final resolver file. That means you might change a DNS server value in one place and still see a different value being used, because another component is generating the effective resolver configuration at runtime. This is a perfect example of what changes where, because the same high-level setting can flow through multiple components before becoming active. The exam-like scenarios where DNS seems to change on reconnect or after reboot, which is often a sign that dynamic network assignment is overriding local preferences or that a manager is prioritizing certain sources. The conceptual response is to identify the managing component and change the setting at the layer that will persist it. Once you see that name resolution is part of the network configuration lifecycle, not a separate magical system, the behavior feels less confusing. A related concept is the difference between per-interface settings and system-wide behavior, because network management often attaches configuration to connections rather than to the machine as a whole. Network Manager profiles are a clear example of this, because a profile represents a specific connection context, and different profiles can have different DNS settings, routes, and addressing modes. NetPlan can also describe multiple interfaces and multiple network scenarios, but it does so in a more static, declarative way. Beginners can get tripped up when they change settings expecting them to apply everywhere, but the system only applies them to the active connection or to a specific interface. For troubleshooting, this means you should always ask which interface you are using and which connection definition is active, because that determines which settings are in effect. For exam questions, the clue is often that wired and wireless behave differently, or that a change works on one interface, but not another. That kind of symptom usually indicates that the configuration is scoped differently than the learner assumed. When you think about failures and weird behavior, there are a few predictable patterns that help you infer which layer is in control without needing to memorize internal details. If settings change when you move networks, connect to a different wireless access point, or unplug and replug a cable, that often points to a connection manager like NetworkManager applying and adjusting profiles. If settings are consistent across reboots and do not vary with network context, that can point to a declarative configuration approach where the system applies a fixed definition at boot. If a manual edit seems to work briefly but disappears after a restart, that strongly suggests a generator or manager overrode it because you changed the wrong file. If DNS settings seem to be replaced with network-provided values after reconnect, that suggests dynamic configuration is winning over static preferences. These are not strict rules, but they are strong signals, and the Linux Plus exam often embeds those signals in the question narrative. It is also worth highlighting a beginner misconception that causes a lot of pain, thinking that there is one single file that controls everything about an interface. Linux networking is more like a pipeline than a single knob, where different components handle different responsibilities. One layer might define what you want, another layer might apply it to the kernel networking stack, and another layer might manage lifecycle events like reconnecting or switching networks. The kernel maintains the immediate operational state, but user space components decide how that state is set and reset over time. NetworkManager and Netplan represent two common ways of deciding desired state and persisting it, but they are not the only possible components in the pipeline. The exam is not trying to trick you into distribution trivia. It is trying to see if you understand that configuration is managed by software layers. Once you internalize that, questions about why changes do not persist become logical rather than frustrating. A strong way to cement the concept is to imagine you are writing down network settings for a future version of yourself, and you want the system to restore them reliably. If your system uses connection profiles and a manager, you want to write those settings into the manager's configuration, because that is what it will reuse when the interface comes up. If your system uses a declarative generator, you want to write those settings into the declarative file, because that is what will be read at boot and used to regenerate backend configuration. If you instead write settings into a file that is merely an output of the system, your change is fragile because it can be overwritten at any moment. This is the heart of what changes where. Some files are inputs and some are outputs, and you should change inputs when you want persistent behavior. Linux Plus questions often expect you to identify whether a file is acting as an input or an output in the configuration pipeline. That reasoning is more valuable than memorizing exact directory paths. By the end of this episode, you should be able to describe NetworkManager as a connection lifecycle manager built around profiles and dynamic network behavior. And you should be able to describe Netplan as a declarative configuration layer that feeds a backend renderer to apply settings. You should also be able to explain what changes where by identifying the controlling source of truth and understanding that some configuration artifacts are generated, not manually maintained. When a network change does not stick, your first instinct should be to ask which component owns this interface and where that component stores persisted definitions. When behavior changes across reboots or reconnects, you should suspect that you edited an output or that a manager is reapplying its own stored configuration. This way of thinking turns a confusing topic into a simple question of authority and persistence. The final takeaway is that Linux networking configuration is not hard because the concepts are complex, but because multiple layers can be involved and beginners often do not know which layer they are interacting with. NetworkManager and Netplan are names for two common approaches to managing desired and persisted network state, and understanding their roles helps you predict where changes go and why they sometimes revert. The phrase "what changes where" becomes a practical habit. You always locate the source of truth, you change it at the right layer, and you interpret symptoms as clues about which component is controlling the active configuration. This mindset also keeps you steady on the exam, because when a scenario describes a change not persisting, you can reason about generators and managers rather than guessing. Once you can tell the story of how a setting moves from a definition into the active kernel state, you are equipped to troubleshoot network configuration on any Linux system you encounter. even when the specific tools and defaults differ.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.